So a few more things. Um, what's coming up next? All of these formulas, all of our percent grade formulas, um, really blend right into our different trig formulas. So in the last example, you can kind of see it here. We were going from some information about the lengths, right? We have the sort of vertical and the horizontal distance, and we're able to sort of reverse engineer our way from that information to how big the angle was. And so what we want to do is sort of connect that a little bit more officially. The idea is we can sort of connect our angle of incline, the sort of angle of elevation, to the percent grade. And so the way this all fits together, right, you can sort of do it in these two formulas. So our tangent inverse of the percent grade divided by 100, all that really does, right, is it converts your percentage back into a decimal value. So that would be the same decimal that you had if you divided the opposite over the adjacent, right? You can kind of see it again up there. So the angle is the tangent inverse of that amount. And so what that means is you can kind of reverse engineer your way. You can kind of unpack this. So that means the tangent of the angle would be the percent grade divided by 100%. So then that means by itself the percent grade would be the tangent value of the angle times 100. So you're just sort of flipping all these different values around. You can either remember this as essentially just starting with the percent grade formula and sort of working everything from there, or you can kind of think of this as just sort of multiple different formulas that are all kind of related. The new information here, right, so the new setup we're doing is we can sort of connect more explicitly the percent grade to the angle. So we did sort of the angle here from the lengths. We did the percent grade from the length, so we can then obviously sort of put 2 and 2 together and get from the angle to the percent grade and vice versa. So for example, so this is an airplane example to get a little bit more of a severe angle on it. So an airplane climbs at an angle of 15 degrees. Find the percent incline of this flight path. Percent incline, of course, just means percent grade. So the idea here is the percent grade would be the tangent of the angle times 100, right? So if you take the tangent of the angle, you're going to get the decimal version of the percentage because it's equivalent to the sort of rise over run, the opposite over the adjacent. So times 100 would be that converted into a true percentage. So if I do tangent of 15 degrees, that's going to be this decimal point 2679. So then times 100%, this is going to be then a 26.79% grade, right? So that's an airplane taking off. You can kind of imagine how steep that is, right? Sort of a 26, almost 27%. You're not really going to see that a lot driving around, maybe a very steep driveway or something going up a hill. You'd see something like that, but really it would have to be a pretty short distance, not really something that would be going for very long. If we look at some of the homework examples where we're trying to sort of make some of these connections, so I wanted to look at number 7 and number 9. So in this next section, right, you are making connections between the sort of horizontal distance and the angle of incline. So if we're given, you can see in number 7, you're sort of given a horizontal distance of 2.5 miles and an angle of incline of 3.23. So the idea is just trying to sort of make some connections there. We're trying to then find the increase in the elevation. So if we do this, right, number 7 here, cover this up a little bit so there's just sort of one piece at a time. You draw a picture that goes with it. We have 2.5 miles going straight across, our horizontal. We're trying to solve for the x, which would be our sort of opposite, that vertical distance. We know the angle here is 3.23. So the tangent value would be the opposite over the adjacent. That means the tangent of 3.23 degrees would be x over 2.5. We can do a quick calculation, just calculator style, write that tangent of 3.23 would be 0.056. So that would be sort of x over 2.5. If you do a quick cross multiply, 2.5 times the 0.056 would be 0.0141. The units there are miles. right? The question asks us to answer in feet. So 0.141 miles, this is obviously a small amount of miles, but times 5280 to convert it to feet gets us 745 feet. So the elevation gain there is almost 750 feet. So again, kind of using this stuff, making these connections. The other one I want to look at, I actually want to look at two. I'll kind of run these back and forth. So question number 9, truck is driving on a road with a 2.9 degree incline. What is the percent grade? So what we're trying to do here is again, sort of make a connection between the percent grade and the angle. So in this case, right, I've got 2.9 degrees here. I don't really know any of the lengths. That's okay. I can sort of make this connection without specifically knowing the lengths. In theory, right, my 2.9 degrees, right, let's find the percent grade. So the grade would be the opposite over the adjacent times 100%. That's our sort of rise over run. The opposite of the adjacent is also the tangent. So if I do tangent of 2.9 degrees, that's going to get me this 0.051. And then that value, just a quick multiply by 100, right? That's going to get me, in this case, to 5.1%. So my percent grade here I can get very quickly if I know the angle, the connection there between my sort of angle and my percent grade. Those are pretty quick to connect, even if I don't know the lengths. Same thing if we sort of reverse it here. So what is the angle of incline, the sort of angle of elevation on a road with a 5.8% grade, right? So what's my angle now if my incline is 5.8%? So just kind of reversing the steps that we just did. Again, the same kind of idea, the tangent of the angle times 100% should be my percent grade. That means then if I do, right, my percent, 5.8%, if I divide by the 100, that would be 0.058. So the tangent of the angle should be 0.058. And so from there, I can use my inverse function on the calculator. If I do tangent inverse of the 0.058, I'm going to get to the angle, in this case 3.32 degrees. So just kind of running these problems back and forth. You know, if you're given one, you can sort of find the other. And that's regardless of having any distances, right? And you could imagine, okay, well, maybe I have this slope and it's going to depend how far I drive on it, would impact what my different distances are. So you could have a slope that, you know, maintains itself for miles and miles and miles. If you only drive over a part of it, you're only obviously gaining so much elevation or sort of covering so much horizontal distance. That's the idea. That's the basics. All right, nice job. We're going to do one more video for this section, and then that'll be that.